Good morning, everyone. Welcome to today's Exploring by the Seat of Your Pants Hangout. My name is Joe Grabowski. I'll be your host for today. And for those who don't know, Exploring by the Seat of Your Pants is all about bringing science, adventure, and conservation into classrooms all across North America and hopefully beyond. I'm so excited for today. Today is round 2 of our virtual field trips to the Bahamas with our new BGAN unit. We're hanging out with a Nat Geo expedition with Kenny Broad and Jill Heinerth. Many of you may have caught their initial Nat Geo hangout a couple weeks ago. A few may have watched yesterday and tuned in to just an awesome hangout with a group from the Bahamas. And this is a full-on expedition going on down there. Not only are they 3D mapping and making virtual augmented reality tours of the cave system, they've got biologists looking at the trees. They have paleontologists looking at what they find in the caves. They have specialists looking at what's edible with the plant life. It's a full-on expedition. We're going to learn a ton today from Kenny and Jill, and I'm excited just to see what happens. We fly by the seat of our pants a little bit, but it's a ton of fun. So Kenny and Jill, awesome to see you again today.
All right.
Great to see you. Welcome to Abaco. I can't quite say sunny Abaco today because we're getting a little bit of weather, but we're happy to have you guys with us on this National Geographic project at the Abaco Blue Holes.
Yeah. So that's Jill, my buddy. She takes care of me underwater. And we're just going to tell you a little bit about what we're doing, and then we're going to try to answer some of your questions, drag in some of the different explorers who are working with the school kids around here. But right now I'm standing over a giant maze that goes miles and miles that has a thin layer of fresh water, and beneath it is heavier salt water because we're on an island and we're on limestone, and limestone is basically hard sponge. So you have salt water that comes in and it's heavier than the fresh water, and that little bit of fresh water is actually where we get our drinking water or water for irrigation or water for industry. And the Bahamas is sort of an example, a microcosm of what's going on all over the world. Because especially you cold people where you have ice around you, you'll appreciate it. But if you take away the water that's locked up in ice, more than 95% of the world's fresh water are in aquifers, these underground reservoirs that we get to dive through. So they're out of sight, out of mind. And hopefully with our mapping, so one of the things we're doing is mapping the area, and you'll get to see how we do that. And that's what takes the cave diving technology. We're also doing water samples where we get creatures out, because what can live in this extremophile environment? And then we take geological samples and we can reconstruct what the climate was like going back. I think the furthest we've done in the Bahamas is 350,000 years, because these caves only formed during low sea level. So if we go back 20,000 years, the sea level was about 400 feet lower. Yeah, than it is now. And the water would drip through the limestone. It gets slightly acidic as it hits the soil. It eats away rooms down there. Stalactites, the ones from the top, stalagmites form that we use for our sampling. But then eventually the ice melts and that water comes up. And one of the reasons we like to study these places is really to try to understand what's going on with climate change right now. Because we can look in the past before there was a human influence and see what happened. And what it tells us is that the climate is very susceptible to greenhouse gases, since the Industrial Revolution. So that's some of the science that's going on. But the great thing, we're working with Friends of the Environment, a local non-government organization, and with the National Museum in the Bahamas, Department of Forestry, University of Miami, all different groups here. And we've got kids running all over the place who are doing simulated hands-on experiences that you'll get to hear from. So I think that's probably enough about what's going on here before you hear from the experts, but we'd love to answer any questions right off the bat.
Yeah. It might seem a little bit chaotic here, but these are all our activity stations happening all around us. So we've got kids in the outdoor classroom here today.
All right, well, let's...
Do we want to open with a couple of questions?
Definitely. Let's start meeting some of our classrooms. Our first group is Mrs. Moore's grade 6s in Winston-Salem, North Carolina. If you want to go ahead and turn on the mic, if you guys have a question to warm up Kenny and Jill, go ahead.
Three of us, you're on next. So grab your stuff.
Can you hear me, Joe?
I've got you.
Okay. My students
Yeah, we can hear you.
Oh, awesome. First of all, we're kind of jealous that you're there. It's a little cold here today. Have you guys ever found any new species while you've been out?
Yeah, we sure have. There's lots of really interesting small animals that live in these caves. And these animals live their entire life cycle in this dark world where there's very little food to eat. So they have some very interesting adaptations that are different to almost anything we find anywhere else. And we actually had a little dive this morning. Christina went in the water and picked up a few of these little critters in vials so we could share them with the kids and show them to them. And at the end of the day, we'll actually let them back into their home again and their environment. So maybe we can grab one of those
Brian,
vials.
can you come over here real quickly? We have a cave creature right here. There he is,
And
Brian
we have a
Cavefish.
crustacean in the vial
And
too.
the vial. And Brian, how many species do you have you found here in underwater caves?
Well, one of the experts, Dr. Thomas Ilef, he's discovered over 200 different species, not just species, but complete new genera and everything. Genera and all these, well, a whole new class. This guy right here, Remipedia, was a whole new class. That's kind of like discovering mammals, right? So this was first thought to be fossilized. They didn't know where they came from. I don't know if you can try to get them a little bit closer. King, can they pick that up?
Yeah, try and bring it in nice and close. As close
All right. Anyway, so this is all right. So this is Remipedia. This is the oldest living crustacean on Earth right now. This guy's been around for millions of years. So we talk about evolution. Well, these guys haven't really evolved because they've been so isolated. They haven't had a need. Their environment has not changed, and so they're a really, really old species of animals. Let me see if I can get him to there. We go right there.
There it is. There you go.
So that's Remipedia. This guy's got a pretty funky name. His species name is Godzilla nomus, so Godzilla gnome, and so he's pretty cool little critter. And we've got 5 different species of. Let me see if we can get him to come back up. Okay, cool. So we've got about 5 different species of Remipedia in this particular cave, which is more than any other cave in the world. So Dan's Cave is a pretty special place because we have these animals that aren't found anywhere else in the world. All right.
So one of the cool things about these animals is that they have fangs, like little pincers, and they can grab onto something like 40 times its size and inject this venom into whatever it wants to eat, turn the insides to jello, and then suck the jello out for food. So pretty amazing survival strategy. So these very, very old animals can teach us something about evolution and survival.
And well, speaking of survival, how do you survive in a cave? Not just diving, exploring it, but even doing science in there. So we have one of our cave mappers, Christina Zanato, who lives on Grand Bahama Island, but that is not a Grand Bahamian accent. That is an Italian accent.
It is a Grand Bahamian accent.
Bella figura. Bella figura.
It is a Grand Bahamian accent. It's a mix.
It's a mix.
Hi, Christina.
So what do I do besides swimming?
Ooh, what's that, Joe?
Or just saying hi to Christina.
Yeah, you know Joe.
Yes, hi Joe. One of the things that I love to do besides going and diving and exploring caves is collecting actually data so that I can bring it back up here. And then we have Sebastian have this amazing software system that he can put my numbers and transform them into lines. And then he can actually overlap the map that we did with the land, and we know where the cave goes. And so we can know even where we walk. It requires a little compass and a little bubble so we can line up to it. And so I have this like a building bubble that I have to do. And then I make sure that it's lined up with a compass, and I take what we call the azimuth. And we have what we call stations, and I write down the depth of the stations, and then the line has knots in it. And that gives me a distance, and so I count how many knots, or the distance dependent, and I write it down as well. And then we put all these numbers, like I said, on the computer, thanks to Sebastian's system, and then that gives us the map. So it's really, really cool to see also the results of your exploration. So I really love to do this as well.
Cool. And one of the things that Christina does is she lays line like a string inside the cave, and that becomes like our breadcrumb trail that we can use to follow out of the cave in case like something happens and it's suddenly too silty, or if our lights go out, we can put our fingers around that guideline and slowly follow that all the way back to the surface. And on that guideline, we put little triangular markers so that we can actually feel them. And the triangles point the way out of the cave. And right behind me here, we've actually set up an artificial cave, like a cave that goes through this wooden box and comes out. And the kids are going to follow this line with blindfolds on and helmets on and crawl through our artificial cave and try and get out in 3 minutes or less. So this is what our little guideline looks like. We have giant reels of this as well for laying in the cave. And these are our directional markers right there. And those can actually just run on the guideline to point our way out of the cave. So that's how we do it.
You go through the cave with your hand on the line, and what Brian says, radar in front. If you don't put the radar in front, you end up knocking yourself in the head many, many times. So we wear helmets, and it's another way we keep backup lights, backup computers. We even take an extra mask. Any problem you have in there, it's not like open water diving. You can't come straight out. You have to find your way out. So, and it's all about keeping calm. So you're better off practicing yoga and meditation than you are doing push-ups if you want to dive in an underwater cave.
So how about another question from another school?
All right, let's meet our next class. We have Mr. Steltman's grade 6s joining us from Oakville, Ontario.
All right. More Canadian.
That's almost my hometown. Pretty close. I'm not hearing Mr. Steltman's class.
Huh. Okay, well, oh, wait, they're playing with their mic. Can you hear me, Mr. Steltman?
We might have muted ourselves. Can we hear it?
Okay, we got you now. Yeah.
Beautiful. I was wondering what the scariest experience you guys have had in the caves has been. Still no?
Well, we've all had scary situations. I think for me, there was a dive where I was first into a very small cave. Like it was only about that tall. And I was guiding a scientist who was doing some sampling. And the scientist got stuck on our way out of the cave. And so that scientist was sort of like the cork in the bottle containing my life too. So we had to work really judiciously to get the scientist unstuck. And we also had a broken guideline we had to patch. And we had a visibility blowout, so there was no visibility, and then a regulator packing it in. So there were all kinds of things. Like when one thing goes wrong, a lot of things tend to go wrong. But the first thing you have to do is kind of stop and take a deep breath and go, you know what? These emotions, they're not going to serve me right now, and just stay pragmatic and make the next best step. And that's what we do for survival as a cave diver, but that's what you can do too anytime you face something that's absolutely terrifying. Just send the emotions away, stay pragmatic, and make the next best step in your life. And that's a good solution. What about you, Kenny?
Yeah, that's what I'm with Jill. And I hated taking tests as a kid. I still sort of hate taking tests. My heart rate would go up. And so what we call sanity breaths, before you even start anything, even in emergency underwater or emergency in the classroom, take a few deep breaths. If you have to talk to a big group, a lot of us don't like doing those sorts of breaths. So yeah, we've had things that they don't even feel scary in the moment, because all you're trying to do is focus on keeping your heart rate down and taking the right steps that you've been practicing and practicing and practicing. So it almost comes naturally. But I guess if I think about something that I think about now and it scares me, is in a cave not so far from here, but in the ocean where the currents change. I went in thinking that the current was going to blow me out, when in fact the current ended up changing when I was in a very sort of tight spot and started sucking in. And it was getting stronger and stronger, and it sucked one of my bottles I was pushing ahead of me and blocked the way, so I couldn't turn around. So, and I just couldn't move it, so I had to come out with only one bottle till I got to one that I left on the way. So luckily, I was paranoid, I was scared, and I had left an extra bottle on the way in case of the worst kind of emergency, which did happen. So when I got to that other bottle, I had plenty of air to get out. But to feel that stuck bottle across the easiest way out, kind of, my heart went up, and it was just close your eyes and breathe.
So we always have a backup plan, a plan B, in case the worst case possible scenario happens. Great question. Do we have some more out there?
All right, let's introduce our next group. We're going to jump to Freehold, New Jersey, grade 5s, Mrs. Hughes class, and I'll turn your microphone on.
Hi, we have David who has a question for the science.
Hi, Mrs. Hughes.
Hi. Great to see you. Do you have something?
Hello.
Mrs. Hughes, can you try that question again?
Sure.
Speak up really
Can you
loud.
try that question again?
Sure. What other animals have you found in the blue hole? What other animals have you found?
Well, sometimes near the entrances of blue holes, we find some pretty interesting stuff. So I've actually spent a lot of times with sharks in the entrances of blue holes, and we love sharks. They're such beautiful, beautiful animals to watch. And to me, there could be nothing more beautiful than watching like the aquarium full of fish and sharks and all kinds of interesting creatures going by while we're sitting there doing our decompression stay at the end of a dive in a blue hole in the ocean. It's spectacular.
Yeah, the ocean holes are amazing because you see it's every color, sponge and shrimps and crabs. And these sharks, a lot of sharks have to move the whole time to keep oxygen going across their gills. And in this case, they just sit there because the currents do all the work for them so they can save energy. So it's really dramatic. But there have been fish here, blind cavefish called Lucipuga here in the Bahamas, and all sorts of neat creatures. And then there's a whole microbial world because some of these holes get studied because they can tell us what the earliest forms of life were like 4.5 billion, that's with a B, years ago. So we have a microbiologist on the team named Jennifer McAlady, who's not here now, but she studies these forms of life to see what life as we know it evolved out of. So when the Earth had these ancient oceans of primordial soup, well, we think some of the holes around here have similar biogeochemistry. So the biology and the chemistry of hydrogen sulfide and no oxygen, they're great places to study. But also, well, you can talk about why we study these for outer space.
Oh, yeah. I mean, studying inner space, it gives us so much information about outer space, whether it's about how teams work together and diving physiology being similar to, issues that astronauts face. We use life support systems that are like the kind that astronauts use. There's so many things that we can do. For instance, a colleague of ours, Dr. Bill Stone, has created an artificially intelligent robotic mapper. So a robot cave diver that can go in and map a cave in 3 dimensions. And he's testing it here in caves so that it can go to Jupiter's moon, Europa, go down through a hole in the ice into the ocean beneath the frozen surface and map that outer space celestial body and send back the information to Earth. So inner space exploration gives us a wonderful opportunity, a fieldwork opportunity for space exploration.
Yeah, some of these animals, especially the microbes that can live in these extreme conditions, they call extremophiles. So if we can figure out what lives in the extreme parts of our planet, it gives us an idea when we study other planets where to look and what to look for. Should I grab someone who knows about what's on the surface?
Yeah, grab someone. We'll get one more question in the meantime.
All right, let's meet another classroom. Right, let's meet another classroom. Lumley's group in Sarnia, Ontario. They're a grade 5 class. Let me just turn your mic on.
All right.
Turn your mic on. Can you hear me, Mrs. Lumley? Can you hear me, Mrs. Lumley?
Don't think we can hear Mrs. Lumley.
All right.
There
We're having. Oh, they're there. All right.
Can you hear us now?
We got him?
All right. Okay, we have a question.
All right. Let's go really loud. Go ahead.
Have you found any objects from the past in the caves?
So, have you found any objects
Great.
from the past in the caves? We're studying the past, and so we
Yes,
want to know.
so
if there's any
archaeology
objects.
is Yeah, so we find archaeological objects in caves, and we also find paleontological remains in caves. So we find things like pottery in Mexican caves, or Brian has found like a Lucayan Indian burial canoe in a cave in the Bahamas. We also find the remains of animals that are no longer here on Earth. So, for instance, shortly we're going to show you a crocodile skull that's been taken out of one of the caves here locally. But I think in the meantime, we also have someone that's going to talk to us about the stuff that we find on top of these blue holes. So Terrence here is from the Department of Forestry, and he's doing some talks with the kids about bush medicine. So teaching them about botany here and what they can make for medicine and nutrition with these plants.
We got Forest Heights. We have some of our Forest Heights students. We got Judah, what's your name? Amanda and Bessie. What grade?
Come on in a little bit closer so the mic can hear you.
All right.
Yeah.
You can go. Okay. Everyone take one. Okay, volunteer. Yeah, relax. No, we're just listening to Terrence. Okay. Go for it, Terrence.
We have here 2 different plants that we use over here for medical purposes. Okay, if you can see inside the pot, I don't know if you can, but that same white flower, shepherd needle. Okay, you can make tea out of this. It's good for if you have pain inside your stomach. You boil this and make a tea out of it, and it's real good. And the leaf also can be used for if you have a boil or bump, any place you can pick the leaf and heat it up, and you put it wherever the boil may be, and it draws the head to actually pop it and get it out of there. All right, we have something that we call wild guava. It's also good for tea. It has little blue or black berries. I'm sure these kids have probably seen it before. The wild guava, sorry. You may call it blueberry, blackberry, but the name is actually wild guava. Extremely good for teas as well. And we also have rat tail. Now, this one here has a better look. It has some little blue flowers on it, so you can identify it. Rat tail, and it's good for worms. So for those of you who tend to like eat candy and sweets and try to get those worms, make rat tail your friend, all right? Because once you boil it, it gets rid of worms. We have a thing we also call strong back. Okay, this is high in iron. It's good for your blood, strengthens your blood, and it's good for your back. We also tend to use it a lot. 5 fingers. 5 fingers. There you go by for the 5 senses. All right. Each one of these with the 5 senses, boil, make a tea, and it's wonderful.
It's got chicken toe too.
Chicken
right?
toe as well as 5 fingers, right? Okay.
Actually, I got a fresh batch of 5 finger here.
We're gonna do some taste testing.
Terrence is our bush bartender, and we have our taste tester. Ready? So we call it 5 finger. Terrence would tell me.
Come on into the camera.
Come on into the
Yeah. Come on over.
All right.
Mr.
Now be honest on how it tastes. They call it 5 finger because it represents the 5 senses, right?
Think it's slow.
A little further. Keep that radar in front of you. How is it? Describe it.
It's like Cersei. I don't
like Cersei, which I'm not sure in Canada if they've tried Cersei.
Cersei is.
Which of the 5 senses is it hitting on you?
Mostly my tongue.
Most of your tongue. Is it sweet, bitter?
It's bitter. It's more than bitter.
More than bitter. We didn't put any sugar in it. Sometimes you put a little sugar in it.
I can still taste it.
Let me try a little. Yeah, it needs sugar. Need sugar. Good. All right. What else we got? What are you holding? Move up to the camera. You can show it.
Yeah.
Mahogany.
Yeah, you can back up. Sure.
And what do you do with the mahogany?
What do we do with them?
Okay, back in the day, this is good for boat building. It gets extremely big, and the natives use it to build boats. And also, what I've learned recently with a toothache that I have, you can peel the bark off a bit and take a piece of it off. And if you clamp down on where that tooth is bothering you, it tends to soothe this enough for you to get to the dentist to get it retracted or pulled out. You know, so it's good for a whole lot of things.
We need something that'll prevent us having to go to the dentist, though, because I hate the dentist.
I know, right? More apples.
All right. Thank you.
All right.
Awesome.
You guys do.
Thanks, guys. Okay, do we have another question out there?
All right, let's meet another classroom. Mrs. Hastings back for grades 8 in Brampton, Ontario. Let me turn. Oh, you'll have to turn your mic on for
All
me.
right.
Oh, I'll have to turn your mic on.
Anyways, this guy.
Hi. How long do you spend?
Hi.
How long do you usually spend down in the caves every day?
How long do we stay down in the cave every day? So sometimes our dives. So sometimes our dives are about an hour or 2 hours. That's kind of what we're doing here for a lot of our dives. The longest dive of this project might be 4 to 6 hours. It requires more tanks, more supplies to do those dives. And some of us have done diving missions as long as 22 hours before. So we need a lot of equipment and support for those kind of dives.
Was there? I was down putting the bushes back, but was there a question about what kind of animals?
Yeah,
we
need some.
So we're trying to get
some skulls.
We should have some fossils up here in a second. But just remember, one of the great things about the Bahamas is that chemistry of the blue holes, where those microbes are using up the oxygen that's coming down through the water. In fact, a molecule of oxygen takes about 8 years just to go 1 meter or a little over 3 feet. So it's very slowly. It's slow enough that that bacteria can use up the oxygen. So you have no oxygen, you have salt water down deep, and that's great for preserving fossils. Some of these fossils look like you ate a chicken bone and threw it over your shoulder, but they may be 4,000 years old. So I'm going to go here. I think I see some of them.
Coming this way, yeah. I think they're coming this way.
Now.
So some of the things that we find in these caves are extinct, so they're no longer here, and it gives us a picture. It's like a museum of natural history. It gives us a picture of what used to live here and what it was like before current times. So Nancy's on her way over here right now with some really cool paleontological remains.
Right.
Nancy's
so
a paleontologist.
Yeah, so we have Nancy Albury from the National Museum of the Bahamas, and
all right,
this is her home turf.
Yeah, so we brought lots of interesting things. These are some of the things that we're finding in the blue holes. We're finding them all over Abaco, and it's telling us about the ecology and those environmental systems from long, long ago. And we already know that the surface environment is telling us what was going on a long time ago as we look into these blue holes, because we can see these animals and go, we don't have crocodiles anymore. So what are we doing with crocodiles in the blue holes? And by the way, there's a lot of crocodiles in Sawmill Sink, a lot of crocodiles. So we find these crocodiles and we said, what is this big apex predator? This is pretty big. Doing here on Abaco, as it turns out, these are actually fossils of a Cuban freshwater crocodile. These freshwater crocodiles, we are living in the land of salt water. And how could that be? Because a large animal has to eat something. There's 52 from Sawmill Sink alone. That's a lot of crocodiles in one place. They had to eat something, though. We really weren't sure what they were eating. As we found out that in Cuba, there's about 3,000 of these left. That's enough to tell you what they're doing. That is the Cubans. The Cubans tell us that they're out in the woods. They go out in the woods and they actually hunt terrestrial animals. That is on land. And how did we find that out? We did a process called stable isotopes, and we found out that, lo and behold, our crocodiles were also eating just land animals, 100% terrestrial. What could that have been? And we started finding tortoises, and tortoises are extinct. These are extinct on Abaco as well. Tortoises are completely extinct. This species no longer occurs anywhere. So it's altogether gone. And then we started finding crocodile bite marks in the tortoises, and we kind of had our answer that in fact they were eating the crocodiles were eating the tortoises. But lots of times this is unusual that we find this kind of preservation. The preservation is a product of the blue holes. The blue holes are spectacular in the preservation. We never find complete shells and skulls. No, most of the time we're only finding one bone like that. I'm going to ask you to hold that carefully from underneath.
Come on, just a little bit closer to
okay.
project.
Okay. So
this tortoise, we poured out the bones of its body, and this is a humerus. So this is your humerus right here. So we poured out the bones we call postcranial bones, came out of this tortoise, and we said, wow, that's pretty neat. Now we know how big its bones were. What happens when we only find one bone and it's all by itself sitting in a blue hole and nothing else is around it? And when you look at them, you can tell that they were the same. They were the same bone, but there's a big difference because this one is like really, really big. So if this bone belonged to that tortoise, we know that this tortoise was huge and really big. They're all gone today. They're extinct on Abaco. And a lot of times we might just find, again, one bone like that. Hold that. Okay, so if you're finding only one bone like that, is it the same? And you can tell that they're not the same. There's a lot of people that say, how do you know about that? Because that bone is a different kind of an animal. How do you know what kind of animal it is? What so happens, it was found with the crocodile. And then we find a bone like that. And we know that the crocodiles got a lot bigger. So we know that the environment was very different on Abaco, just given these vertebrate fossils. There's birds, there's giant owls that we found in the blue holes that are all gone today. They're extinct. And so these giant owls were about 3 feet tall. We're not finding them on Abaco, but in other blue holes. So it's not just one blue hole that's producing spectacular fossils. Okay?
Cool. Yeah, thank you. Thanks, Forrest Heights. Okay. All right.
Cool. So we have another question, Joe, from another school.
Absolutely. Let's jump to Mrs. Wilson's group. They're in Freehold, New Jersey, a grade 4 classroom. And your microphone's on.
Hi. Hey, go ahead, Sam. Start. Are there any plants? And if there is, did they make any adaptations to live in there?
Did you hear us?
Are there any
plants? I missed a word. Plants, did you say?
Yeah, they're wondering, are there any plants and what kind of adaptations do they have to live in Abaco? Are there any plants and what kind of adaptations do they have to live in Abaco?
Oh, plants in the cave, right? Or plants here? Actually, we should get our forestry team. Should we hold that question for the forestry team? Because I don't really know as much. There have been all sorts of adaptations. You can see the pine forest that we're standing in, that we move around, that are adapted for recurrent fires. And the seeds, that helps the seeds get dispersed in the right way. So there's all sorts of different adaptations, but I think we have people who are studying that.
Yeah.
I'm gonna go grab Tom.
Okay. There's also like animals that have really interesting adaptations to caves as well. So for instance, in like ocean blue holes, just outside an ocean blue hole, we might find a sponge, and that's an animal, right? So the sponge might have like antimicrobial features and anti-cancer features that might even be interesting for creating new chemistry or new pharmaceuticals. And we find a sponge that's not exactly the same, but similar inside the cave. And those sponges might have an unbelievably higher potency of the similar components. So a higher antibacterial characteristic or a higher anti-cancer potency. So it's really interesting what might live in caves. The crustaceans are also like similar in a way. Like in the river, we might see a crustacean that's got color and it's got eyes and it lives 2 to 3 years. But if you find a crustacean inside the cave, like a crayfish, it's white, almost clear. There's no pigment because he lives in the darkness. So there's no need to have like showy colors to show off because there's nobody looking in the dark. And he has no eyes, so he's blind and albino. But other than that, his body looks really similar to a crayfish that's outside the cave. But the cool thing is that some of those crayfish that live inside the cave live for like 200 years rather than 2 to 3 years. So there's definitely adaptations of similar animals outside and inside the cave. But here, now we've got our little tree and system biology specialist, Tom Morris, and he can tell you more about what he's doing.
Hello, kids. Tom just turned 70 3 days ago, so happy birthday, Tom. Woo! And he's still cave diving hard.
It's here for the old guys.
Yeah. You're in charge of helping Tom.
So we were just out in the woods here with these students talking about the Bahamian tropical pine forest. Locals call it pine yards. And it's kind of a special kind of forest. It's only found in the Bahamian archipelago. And it's most common up on the 3 northern islands and a little bitty bit down on the Caicos Islands in the south. And so we were looking at how 3 things that foresters look at to measure the health of pine trees. They look at how tall they are, how big around they are, and how old they are. And so we were looking at these little cores of wood that people have cut little pancakes out of a tree, and you can count the growth rings. So I don't know if the camera is good enough for these kids to count growth rings. Here, I'm going to count on this side, and you guys count on that. Closer? Cool. Count. You guys count. It's like start in the middle at the bullseye and then count those rings all the way to the outside. 1, 2, 3, 4, 5, 6. I got 14 rings. They get kind of small out towards the end and harder to count, but you guys probably have better eyes than an old guy like me, so maybe you'll pick up another ring or 2. Well, that's one of the things we look at. We have a little tool. Now, if you had a pine tree in your front yard that you really liked and you were curious as to how old it was, I guess you could take a saw out and cut the thing down and count the growth rings.
Back up.
But
we're going to show them how we core a tree. Tell them how to core a tree.
But that might not be so good. So we have this tool called an increment borer that we screw into the tree, and we can extract a thin little cylinder of wood, and we can count those growth rings.
All right, we got it in there.
Do you count 70 rings?
70 rings.
Yeah.
In 2 days.
So the oldest things in the world are the bristlecone pines, and they're almost 5,000 years old. And they don't want to cut the bristlecone pines down to find out how old they are. So what they do is they use that same tool, and they extract a little core of wood, and their growth rings are so tight on those trees that they have to use a kind of microscope to count the growth rings. So anyhow, so kids, what's one of the things, the adaptations that these trees have for life in a forest that burns up every 3 to 5 years?
Long and close.
Fireproof. Well, the bark on the trees is fireproof. So whenever the forest fires start up, it burns away all the undergrowth, so the baby pine trees can grow up, so they have like fireproof bark to protect them from getting burned down.
Very good. You get an A for sure. And yeah. So when we walk around here, we see that charcoal on the sides of the trees, don't we? On all the trees. So when the shrub layer gets too tall, the baby pine trees, they kind of die in the shade. So yeah, we got the Bahamian pine forest.
Do these pine cones need fire, or they don't necessarily need fire like some places?
Yeah, some of the pine cones open up just naturally, but others, when the fire comes through, the rising heat of the fire will cause the cones to open up and drop their seeds. And so that's the perfect time to put your seeds on the ground, because the shrub layer is burnt down, so there's lots of sun for the babies, and the ash that's left over is kind of like fertilizer. And so when the first rain comes along, the baby pines come up like grass in your lawn. Yeah.
I think we can, if there's questions for Tom, but also any questions for the students here about what it's like to be out here either today or just living in a completely different sort of place from where you all live. So Joe, if you could field some questions would be great.
All right, well, let's meet another classroom. Mrs. Altman's class is joining us from Virginia Beach in Virginia. And your microphone should be on.
How are blue holes formed?
So,
we try that again?
Yeah, go ahead.
Blue holes formed.
I couldn't catch that.
How blue holes formed?
So they're wondering,
how do blue
holes?
form?
Yeah. Yeah.
Oh.
Tom
knows a lot about these.
How do blue holes form? Well, the rock around here is made out of limestone, and when rainfall falls down through the atmosphere and then trickles down through the soil in the ground, it picks up carbon dioxide And that's the same stuff that we've been talking about with global warming, right? The CO2 that we're producing by burning fuel. But it picks up CO2 and that forms a weak acid. And it's almost kind of as acid as like lemonade. And when it drips on down through the rock, it dissolves it away and leaves these big caverns. And they fill up with water and we have a blue hole. It's as simple as that.
All right, good question. Do we have another one out there?
All right. Well, I have a question for maybe one of the kids. I'd like to hear a little bit about what your typical school day is like. See how it compares to ours here in North America.
Okay. Come right up here. Who wants to talk?
Typical school day.
Come on.
All right. You're it.
Yeah, you're
Get
it.
up there.
Come on in.
How do you get to school, Ethan?
Yeah, how do you get to school?
We have to ride a ferry, a boat to get to school every morning, and then it's like a 15-minute drive from the dock to the school. And then it's really hot outside, but besides, we have air conditioning in most of the rooms, so it's just, I don't really know.
So what happens if the weather's bad? Can you still ride the ferry?
Yes.
Oh, so you don't.
Depends how bad the weather is. Like if it's like a hurricane, of course we're not gonna come. But if it's just like a thunder rainstorm, yeah, we'll still come over.
Cool. So like you guys at a lot of the schools that we're talking to have snow days. These guys might have like bad sea state days.
And when does your school day start and end? What's a typical school day hours?
We start at 8:45 and end at 3 o'clock. But for the people that go on the ferry, it takes us until like maybe 4:10 to get home.
Cool.
All right.
Are there any kids that get seasick when they're on the ferry?
No. Actually not.
I can say that.
All right, we got some more questions.
All right, let's meet another classroom. I believe we have not visited Mrs. Phillips, grade 5-6 in Georgetown, Ontario. Your microphone's on.
I was wondering, how will you be able to change the world with your research?
How will we be able to change the world for research?
Yes.
Well, my generation and Tom's generation has kind of messed it up. So we're really counting on you guys, quite frankly. But a lot of what we do here involves like studying things like climate change. So if we learn about the past, then that helps us, predict what might be happening in the future. But we're really relying on you guys to be a lot more proactive and use your opportunities in this global connected world to combat global climate change, for instance, and come up with cleaner solutions for generating power and better solutions for resource management. And all of that's really, really important.
Hi, my name is Adriana and I'm from the National Museum of the Bahamas. We're here today working with the pingers and the kids. So we're showing them how the pingers work. It's also known as cave radio. This is what a pinger looks like. And our diver takes it with him underneath the cave and puts it in a location, and above ground we track it using this receiver system.
Show them how they do it, Andrea. Yeah.
Okay, yeah, so you want to keep this level at all times, and you kind of want to maneuver it from left to right so you could get the different sounds. So when you map the cave, sometimes you hear a null sound, sometimes you hear a soft sound, sometimes you hear a louder sound. So we want to go for the louder sound, so that means we found the pinger underneath.
So the kids have been using this device and learning how to track and find the cave, and they were pretty surprised to discover where the cave was beneath their feet. So what did they learn?
We actually planted the pinger underneath the porta potty. And so the lesson in that is land use. We don't want to place our cesspits above or within the ground where we have cave systems, because our bedrock, which is limestone, it's porous and it absorbs anything that we put on or within it, and it can leach into our cave system which is the same place that we get our drinking water, and we don't want that.
So the kids were tracking and tracking and tracking and zeroing in on the signal, and then they found the signal right beneath the porta potty. And it's a great opportunity to learn those lessons about what we do on the surface of the earth, ultimately coming back to us in our drinking water.
For those of you, porta potty is a latrine. It's our field bathroom because we don't want stuff to go right down in. So we clean out the bathroom every day. We flip a coin to see who does it. It's either Jill or I. And this is part of our project, is to ping in different parts of the cave so we know where in the forest the main passageways are going. So it's all sort of interconnected between figuring out what's going on land and how to best manage what we do on land to minimize the impact on our groundwater.
And answering like the last question from the last school, that's one of the ways our research can really help humanity, because if we know where the drinking water conduits are directly beneath our feet, we can be really responsible with what we put on top of that landscape that's very, very porous. And basically, if you think of these caves as the veins of Mother Earth carrying the sustenance, that clean, crisp drinking water, then you'll start to think about what you do on top of them.
So no pressure, Adriana, to keep our drinking water safe for the next many years.
Yeah.
So, anyway.
Awesome.
Probably you can ask lots of questions from many of us, but we also have, we have our representatives from the National Museum here who also know a lot about the fossils. They know a lot about the area. So any questions, Joe, on your side?
Okay, well, we visited every classroom, so why don't we do this? Anybody in a classroom has a question for the museum team about maybe the fossils or the pinging, why don't you come up to the camera and I'll pick your classroom. We'll get questions out. As well, I want to remind our viewers, as well, are watching live, to send in questions on Twitter with the hashtag exploring by the sea. We'll get you a Twitter question or two.
Great.
Oh, here's someone from Mrs. Phillips' class.
Okay, go ahead.
Has pinging ever got you out of hydrogen sulfide?
Can we get a repeat on that?
Should I do it in 3 minutes? Has pinging ever got you out of hydrogen sulfide?
As pain?
Hydrogen sulfide.
Does it cause pain?
They're wondering
if you stay in it long enough.
They're wondering if. Sorry, they're just wondering if the pinging system has that ever gotten you out of maybe trouble in the cave.
Oh,
okay.
I would say no. It's not a tracking device for when we're in the water. It actually helps us on the surface track where the cave goes. So really, we just place it in one place and we'll tie it to the ceiling and it floats a little bit. Then we'll dive back out and work with the team to find it. So it helps us make the cave map more accurate, which helps safety also, but it's not what we use to find our way out.
All right, then.
That's so funny. I heard pain and hydrogen sulfide.
I heard pain and hydrogen sulfide too. Maybe it's our subliminal.
Hey, if we look over our shoulders here behind us, you can see the wooden cave that the kids are crawling through right now, and I see the cave is shaking, so that means there's a kid coming through the tunnel, and they're hanging onto that guideline and bumping into these line arrows that direct them through our cave, and then they're going to emerge out of beneath that table there in a moment. And here we go. I see a hand. I see an arm.
And we heard a bang.
We heard someone just hit their head. Uh-oh.
The line is your friend.
Oh, and he's only got like 30 seconds of breathing gas left.
Running
so
low on gas. Running low on gas. He's got his radar out. 10, 9, 8, 7. Yay, survived. Whoa.
He made it.
All right, very cool.
Well done.
I can see someone in Mrs. Hughes' class is up at the camera. Mrs. Hughes' class, go ahead. Class, go ahead. You got to come closer.
We
to
need
the
that a little louder.
You got to come closer to the mic.
What food do the animals in the blue hole?
Let's see if there's any more questions.
What food do the animals in the blue holes eat?
What food do the animals in the blue holes eat? Well, interesting stuff. Sometimes they eat each other. So sometimes when we collect these animals for study, we have to be careful to put them in their own jars, because if we share jars with them, suddenly they start gobbling each other up. But also, some of these animals live chemosynthetically, so they're living off of some interesting bacteria and algal colonies. So there's not a lot of food inside of caves, and so they have to have a very they might eat me too. In fact, that's how we catch some of these red shrimp, the barboria. We go just inside the cave and we carefully lay our hand on the dirt, because they're feeding near the entrance of the cave, and they'll slowly crawl up on your hand and they'll start chewing away like at the edge of your dead skin on your cuticles and fingertips. So pretty interesting stuff. All right, I think we're fetching Corey right now. If we've got a couple minutes, we're going to bring Corey over here. Corey Jaskolski is the Innovation Fellow from National Geographic, and he's doing our augmented reality experience here. So if you've played Pokemon, then Corey is your guy, because he's created the software that enables us to scan things in 3 dimensions underwater and project them in what we call augmented reality. So here comes Corey and his group with his headset, and he's going to tell you quickly a little bit about that.
All right, pop in here with you guys. So come closer. All right, there we go. All right, so I'm Corey Jaskolski. I'm a fellow at National Geographic, and my specialty is in high-tech imaging that allows us to make 3D models of the things that we find underwater and above land too. But we can do it in a way that we don't have to take the object out of the cave. We can actually scan it and build a 3D model and then show everybody that 3D model without ever having to remove anything or disturb stuff from the caves. So I was just showing these guys from Forest Heights. You guys are all from Forest Heights? Cool. Forest Heights Academy here in Bahamas, our augmented reality headset. And what this does is you put it on like a pair of sunglasses, and right away you look pretty funny, but you know, I'm used to that, so even without it. So at any rate, it just looks to everybody else. Nobody else can see anything except for the TV and the camera here. But for me, I can see a whole bunch of stuff that we found underwater. I see a map of the cave all winding around through the trees behind me. I see a crystal column that I'll show you in a minute on the phone. A big calcite crystal column that we found underwater in 3D scan. And I also see a human jaw that we scanned in Mexico near Chichen Itza. And I'll show you, because I can't show you through the headset. I can kind of show you on the phone, I hope, a little bit.
Here, you wear the headset and I'll try and tilt it.
Fairly dim there, maybe. Yeah, that's a stalagmite formed out of calcite that that might not work great. Yeah.
Yeah.
That's what a cave looks like. That's what a cave looks like. Right.
Yeah.
So there you go. Hey, and you guys have another fun activity to hit while Corey finishes up. Yeah. Hey, Maria. Maria, our National Geographic ethnobotanist, is coming through. And one of the things about living in the field, because a lot of us have been camping out here, you start to smell. Sometimes we run out of toothpaste. Not a problem when we've got an ethnobotanist on our team. So she's going to describe a little bit about how the plants can be used for personal hygiene, among other things.
All right, and you guys all know this well, so you're going to hang with me. So I was one of the people camping out here last night. Although I think I smell fabulous, I might need a little bit of help. So with these, and this is one where all of you guys all know what to do with this. You pass that. Let me take one. You guys pass them around. So you've got your, what we call, you guys remember what it's called? It's like that was a whole thing ago. Soap bush. So not too tricky for a name. And you take it and you're going to rub it and it makes your skin really smooth. And when you smell it, it actually smells pretty nice. So this is one Before people were using soap like we used to. I don't know if you guys can see off camera, but the whole crew is now using this. Fun to be here. Okay, so that's one thing you would use. And then also, again, personal hygiene. You guys remember this one? The tooth. The tooth. So this one is called white sage. And one, if you can make a bath, just take one. Oh, I see you over there. Yeah. So this is one, you can make a bath with it if you have chicken pox. But then a use, actually, a new use that we're learning. You wake up in the morning, you're kind of take one of these. You guys ready? Oh, you're all on it. And you, oh yeah, oh, I'm so clean. And it really does feel clean. And you lick your teeth, and it helps clean your teeth and kind of makes your breath smell fresh. And these are all things that are growing all around here. All right.
All right. Thanks, Maria.
And you guys.
So I don't know about everybody else. I just tried this soap bush, and it's just not cutting it for me. In fact, I think I killed the tree. So. All right, I think we're getting close to our end here. Joe, do you want to give a call out to all the kids at each school?
Yeah, well, let's steal one question from Twitter to wrap up. I have a question that came in on Twitter. So they're wondering about divers. What's the youngest age that somebody can start diving?
Well, you can start diving when you're 10 years old and do a junior scuba diving certification. So you could start really, really young. That's much younger than when I started, and I wish I'd had that head start. It's a lot of fun, and whether you want to do exploration or careers like this or not, it's incredible to experience the underwater world.
Okay, and I think we can squeak one more, and it's about the robot cave diver. This is from Twitter as well. Is it run with code?
Yeah.
Is it run with code?
Yes. Yeah, there's a lot of code that goes into a robot cave diver because it's artificially intelligent. So it's able to swim through the cave and look at tunnels and view and spin around and decide, I think I'll go this way, not that way. So there's a lot of code that's in a robot cave diver. And this particular one has been in development for 20 years. So a long time.
But we don't want them to put us out of business. So we don't want the artificial intelligence to get too intelligent.
Yeah.
We need job security.
Yeah.
All right. Well, Kenny and Jill, another great hangout. I love how vibrant your expedition site is. People are moving. People are having fun. You can hear people laughing and bringing the kids there and sharing the laughing. That is such a great idea. I want to thank you guys again for these hangouts, and maybe just wondering how much longer you're in the field.
Until the 19th of December.
Yeah, so we're going to go home for Christmas.
All right. Well, we're going to give the classrooms a chance to say goodbye and thank you.
There's links to.
Thank you.
Hey, every night we do a video and a post, so you can follow what's going on and hear more about some of these topics on the National Geographic Voices. We'll send you, Joe, the link so you can send it around.
Yeah, so you can see our expedition each day as it progresses.
Perfect. I will pass that link on to the classrooms from today and yesterday. And for right now, though, we'll turn on the mics and let the classrooms do their thing.
Thank you.
Okay.
All right.
This is my favorite part.
Well, thank you, everybody.
All right.
All right. Bye, everybody.
And good luck with the rest of the expedition.
Yeah.
All right.
All right.